Physics part 305. The figure shows an arrangement of the capacitor. Calculate the capacitance of this arrangement. The 4U farad capacitor is disconnected. Calculate the new capacitance. Number 3. A 10U farad capacitor is charged from a 9.0 volt battery. Calculate the electric potential energy stored by the capacitor. Calculate the charge stored by the capacitor. The charge capacitor is discharged through a 150 kilo omega resistor. Calculate the initial discharge current. Calculate the time constant. Calculate the time taken for the current to fall to 3.6 into 10 power raised to minus 5 amperes. Gravitational fields. Well, at the end of the section for gravitational field, you should be able to recall and use Newton's law of gravitation in the form F is equal to G into M1 into M2 into a sum divided by R square. You should be able to show an understanding of the concept of the gravitational field, an example of the field of force, and define gravitational field strength as force per unit. You should be able to derive from Newton's law of gravitation and definition of gravitational field strength the equation G is equal to Gm over R square for the gravitational field strength of the point mass. You should be able to recall and solve problems using the equation G is equal to Gm over R square for the gravitational field strength of a point mass. You should be able to recall and solve problems using equation G is equal to Gm over R square for the gravitational field strength of a point mass. You should be able to define potential at a point as the work done in bringing unit mass from infinity to the point. You should be able to solve problems using the equation for the potential in the field of a point mass. You should be able to recognize the analogy between certain qualitative and quantitative aspects of the gravitational field and electric field. You should be able to analyze circular orbits in inverse square law fields by relating the gravitational force to the centripetal acceleration it causes. You should be able to show an understanding of the geostationary orbits and their application. You should be able to show an understanding of the geostationary orbits and their application. Force between the masses. We are familiar with the fact that Earth's force of gravity is responsible for our weight. The force which pulls us towards the Earth, Isaac Newton concluded that the Earth's force for gravity is also responsible for keeping the Moon in the orbit. His calculations showed that Earth's force of gravity extends into space but weakens the distance according to an inverse square law.